Hey folks, welcome to the channel. Today is the final part in the bandsaw conversion series. We're going to put it all together and try out some test cuts on some aluminum and some steel. See how it works out. Alright, let's get started. A YouTube subscriber asked for more detail about how I made the cutouts on the large pulley. So let's start there. I think it's done on here, front, yeah. Okay, we're going to do it on there. All right, we're going to create a 100. This is just a reference circle. It's 120. Okay. And then from there, what I did was I put a single circle here of 40. All right. And this is what I started out with. And let's make this construction here. All right, and then I use the circular pattern tool, and I created 7 of them. Okay, and at this point I thought, you know, that looks fine. That looks like the original pulley, but let's try to snazz it up a little bit. So then I just created a couple of boundaries. I created this one out here, and then one in here, and then I have one here, like that, and then I have one here, like that, okay? All right, and then I did a bunch of trimming, and let's see, I'm gonna trim this, Okay, so now you could start to see the outline. Now I got to go in and delete all these other parts because I don't have anything yet. So and there we go. Okay, and then the last little thing is we radius this. I don't remember exactly what I had. I know it wasn't that. Let's try 4. 4 looks pretty good. We'll do that. And try 4 on this. 4. Yeah, that's probably it. Oh, I got a little more trimming to do. I got this little piece here. And then this little piece here. Okay. All right. So now what we do is we use that circular pattern tool. And I think I can select a lot of it this way. Yes. Okay, I'm holding down Shift key. So I've got the items are 17 segments. Choose the center point. And there's 3, 4, 5, 6, and 7. Boom. And there you go. So you'd finish it, and then we'd extrude it to cut it. So, but that's how I did it. And like I said, I drew 7 circles, and then I looked at it and I go, well, let's make it look a little cooler. And that's how it is. The belt tensioner is several 3D printed parts. First up is the pulley. It looks pretty big here. It's only about 25 millimeter. It rides on 2 bearings and a 6 millimeter pin. Next up we have the arm that pivots out to apply tension, and there's a top and a bottom part to that. And here's the top part and the bottom part. There we go. We also have a mount for this. Gets mounted to the bandsaw housing. This space in here, it sits 3 torsion springs, and there's a 3 millimeter pin that everything pivots off of. We can look at it. We have assembly here. It doesn't have the pulley on it, but you can get an idea of how this is put together. The torsion springs right in here, and this gets screwed together with 2 M3 screws and some nuts, and there's a third M3 screw that just goes in and threads into this piece over here. We also have a few spacers. We need to move the door out, clear the pulley that we've added to the wheel. So we're spacing out the door by about 20 millimeters, 3/4 of an inch roughly. This sits under just sits under the door. And then on the right side, there's also another spacer. Here's the belt tensioner pulley, the mount with the torsion springs, and the assembled belt tensioner. I assembled the pulley according to the animation. I needed to trim about 2 millimeters off of them. They were a little bit long. All we need to do now is put the bearings in them. These are 10 millimeter ID. 26 OD by there's 6002 RS is the bearing number. So we'll just push these down in. The big pulley gets 2 of them. There we go. And then the small pulley gets a single bearing. So that's how that all fits together. And this is the shaft. Let's see. Turns on there real nice. Ready to assemble the saw. One of the modifications I made off camera was the original vacuum hose mounts to the back. There's a little vacuum hose bib, and it mounts to the back with 3 screws. I use the 3 screws for my idler pulley or jack shaft mount. So I needed to trim away a little bit of this right here to clear the pivot or the shaft. So that's what I did, but that's about it. So let me set the camera down. I'm going to tilt the saw, and you tilt the saw down. Okay. So here's another look at that. But I've already got I used, instead of the serpentine, the original serpentine pulley, I have a 20 tooth HTD 5M pulley, aluminum. I'm going to replace that, probably drop it down to about a 16, but for right now that's what I have, and that's what we use for assembly. So let's take a look at what we have. Originally we have the cover here, or the door. So the door goes there. After the pulley is in place, I needed to 3D print some spacers to raise the door up. So these are the spacers for the door. There needs to be one more to cover a gap on the top, which I'll 3D print, and I'll include that in the a link to where you can find that in the description. This is the idler pulley or jack shaft mount. This is what mounts to those 3 holes where the hose bib is. It's 10mm shaft. Here's our idler or jock shaft pulley. So this got assembled with the M3s. I think they were by 35, M3 by 35, 8 of them with nuts, squeezing this together. There's 2 bearings on the big end. These are, let's see what size they are, if I can see it. I'll list it in the description. These are 6000 2RS bearings. They're 10mm ID 26 OD by 8. All right, here is a belt tensioner. This is all 3D printed. There's a tensioner mount, a top and a bottom for the arm, and then the idler pulley. It just follows the belt around. The bearings are, I'll have to look what these are, 6003s maybe. These are 6mm by 16 by 5. So there's 2 bearings, one on each side. I've got it held in place with some M3 screws. These have nuts. The idea is to squeeze this, hold it together. In the along that weak plane, they were printed vertically, so we'll try to squeeze it together. This last third one is just threaded into this part here. It's a longer M3. I've got some torsion springs. I got 3 little torsion springs, and provides a little bit of force. It's just enough, so it should be good. So that's the belt tensioner. Here's the pulley for the wheel where the belt or the blade goes around. Here's I don't know if you can see that. This is a 59.5 inch by 1/2 inch by 0.025 inch. I assume that's the width, the thickness. 24 tooth per inch. That's it. This is a bimetal blade. All right. And you can't use a wood blade, obviously, if you're cutting metal, so you have to go to a metal blade. This one's supposed to cut soft metal. We're going to try it on steel. Hopefully it'll be able to cut steel too. But if not, then to cut steel, I'll have to get a better blade. Here are a couple of belts. I'll list the length, and these are 5M belts. I'll list the length in the description. And some tools. So that's about it. So we're going to tilt this up and just first put on the pulley mount here. Okay. We'll move the camera. We're going to get this in. I'm going to start one of the screws, and then we'll turn it around and we'll look at the other side. All right. I'm going to flip this down and we'll take another. Actually, let's go over here. Got a little spacer here. This goes down here. We have 2 belts. We'll use the shorter of the belt. Just put the belt around the idler pulley. Yeah, we'll tighten the belt once we get this mounted. You have to put this in first because there's not a lot of room between the edge of the pulley and the side of the case. So slide it in the way I did and put the other mounting screws. So let me tip this back up. All right, while I'm in here, I'm going to tighten the motor and adjust the belt tension. All right, lay it back down. Next up is the timing belt tensioner. Okay. Need to put on the blade. I think our tension is too tight here. Let me change the angle of the tension a little bit. All right. Got the circlip. Okay. All right. All right. Now for the cover. Here. Close this cover here. Okay. You have a couple of spacers here. This new spacer, I took the original socket head cap screw out of the cover and then just added it to the spacer, so it'll lock down on the spacer instead of the cover. And so we just mount this first. Okay. There we go. Moment of truth. Let's first try cut of the 1/8" aluminum. I think it's T6061. that cut nice. That cut fine. Let's go up a little bit in size. This is half by 5/8 or 5/8 by 3/8. T6061 aluminum. That one took a little more force. Let's try a little thicker steel. Here we go. This is about an 1/8 inch. Let's give this a go. 1/8 inch steel. Well, it cuts. Well, it's not the fastest at cutting, but it does get through the metal, and the blade seems to be okay from what I can tell. See how long the blade lasts. I am going to slow it down a little bit more. It's probably traveling a little bit fast. I'm going to put that smaller 16 tooth from a 20 tooth pulley on the motor, and that should slow it down quite a bit and help it out a little bit. Let's take a look at it. We're going to call that a success. All right. Well, thanks for watching. Thanks for following along. There's one more look at it. Move the light. Right, well, it turned out quite well. Pretty happy with how everything fell into place, and just enough room to get everything to fit inside the housing. I did have to move the door out. Here's that gap I'm talking about. So I'll 3D print a spacer and mount it to the door, and then we'll cover that gap up. But that's about it. All right. Thanks for following along. If you like the content, hit the like button and subscribe, or leave a comment. Thanks for watching. Take care.